Hello and welcome to MATLAB course. This is Salim. In this video I'm going to talk about the subplot in MATLAB. Subplot, it means that inside one figure we have a subplots inside that one. So we can compare them or show some details, something like that. Let's check how to do that. In MATLAB, the general form to do subplot is like the subplot M and B, where M and N is representing the number of rows and number of columns. So M is number of rows and N is number of columns. Whereas B is represent the position of the subplot. What does this mean? For example, consider that we have 3 rows by 2 column subplot. So here we have this black frame and we have 3 rows and 2 columns. So M by N is 3 by 2. And the B will be the position. For example, we have this 1, 2, 3, 4, 5, 6. So the position, how they called? So the notes, it say that the position of subplot is counting from left to right and top to bottom, so usually we started from left to right and then top to bottom to call the subplot. And let's consider this example, quick example, to know about the subplot. So here it's required to create one subplot with 2 rows and 1 column. To plot y1 is equal sine x, y2 is equal cosine x, in the range of x between 0 to 360, and the 2 subplots have the 2 function, which is y1 and y2. Let's open MATLAB. This is MATLAB. Let me open the live script. This is the file I use. Live script now open. Let me minimize all the current folder, the command window, and the workspace. Just click the action icon and click minimize. Here, minimize. Here, minimize. And if I check here, this is the same question. So we need to define x first. So x is equal to line space between 0 to 360 and number of elements, for example 40. Semicolon to suppress the output, and then define y1, which is equal to sine, and because the x is in degree, so it should be sine d of x, semicolon, and y2 is equal to cosine d of x. And now we define the input data, and we need to create subplot from 2 rows and 1 column. So subplot 2 rows, 1 column. As we have 2 rows and 1 column, it means we have 2 like the plot or subplot like stacked together in the vertical direction. And then we should define the B, and the B is kind of the position. So let's consider the first one, which is mean the first row. And let's draw, so plot x comma y1, and let's run the section to check what will be the output. So now we can check that we have this window, and inside that window we have the 2 rows and 1 column, but we draw in the first position, in the first upper one. We can check that if we click here and click like open in a figure window, so we have this window, but we doesn't draw in the all, we just draw in the first part. So if we go to again to the subplot and then 2 rows, 1 columns, and then the number 2, which is the position number 2, and then inside that we write plot and then x comma y2, and then run the section. If we run the section, now we have 2 rows, 1 column. The first one we define, and then the second one. So it is very easy, very simple. Just define how many rows, how many columns, and then call the position B, and then define that. Let's check the second example. In the second example, we need to create one row and two columns. So the previous one was two row, one column. Here, one row, two columns. To plot the same, which is y1 sine x and y2 equal cosine x in the range for x of between 0 to 360 and with some format. And the format, it say that we need to adjust the y-x limit between minus 1.5 to 1.5 for both subplot, and also we need to insert the legend, which is y equals sine x and y equal cosine x. These are the equation. We need to insert the equation as a legend for each of the subplot. Let's do that. So we can define again x. So x is equal to line space between 0, 360, maybe the number of elements here 100. There is no difference. We can select any number, but of course increasing the number of elements will increase the accuracy or the appearance, improving the smoothing of the curve. And then define y1, which is equal sine d of x, and then y2 is equal cosine d of x, and then run the section. Now we define we have error. This is 0, not O. Run the section. And then we have the input already defined. So we need to draw one rows and two columns. So subplot of one row, two column, and the first element. And we need to plot x, y1. Let's check what will be the output. Now we have this figure window, and inside the figure window we have one plot here, but still the second plot in the second column we don't draw. So let's put subplot, one row, two columns, and then the second one. And inside that one we will write plot and then x, y2, and the section. Now we have one row, two columns, and each it have the same shape for that one. Of course, the shape you can check it's slightly different because the altitude or the height of the shape, but still the same function. So if we need to set the limit, this is very important. Let's check. For example, if we go after the first one and we write y limit, instead of here the y limit is minus 1 to 1, here the limit between minus 1 to 1. So if we need to adjust the y limit, we need square bracket and say minus 1.5 to 1.5. And let's run this section and discover what will happen. I adjusted the y limit for the first subplot, and if we check, we have the range here. But the second one doesn't change. Why? This is very, very important note. Every subplot, for example here, every subplot is separate from the next subplot or the other subplots. So if I change anything inside this subplot, will not affect the other subplots. For example, I change the y limit in the first subplot, but the second subplot will not affect it because it's separate from the first subplot. But what if I need to adjust the other subplot with the same range? Okay, so in that sense we should write y limit is equal to, and then from minus 1.5 to 1.5, and then run the section now. And now we have same range from minus 1.5 to 1.5. And the second thing is we need to insert the legend. Again, we can write the legend, which equal to y1. We can write underscore 1 to have kind of the subscribe of the number 1, equal to sine x, and then let's run the check. I wrote the legend for the first curve here, for first subplot, so it's shown only for the first subplot. As we mentioned, every subplot have its own configuration. Once we change something in the first one, it doesn't affect the other, it only affects that one. So if we need to show the legend for the other one, we just simply write, this is legend, and then we can write inside that one, for example, y underscore 2 equal to cosine of x, and then run the section. And because we write now that this legend in the second subplot, it's shown in the second subplot. So this is very important again. What we change for each subplot, it affects that subplot only, it doesn't affect other subplot. Okay, let's consider the following practice. So create a figure which is divided into 3 rows and 1 column using the subplot, and plot the function, the following 3 function for the range of x between 0 and 10 in these subplots. So the first function is y1 equals sine x, y2 equals sine 2x, y3 equals sine 4x. And we need to adjust the following things based on the format they give for us. For example, in the first one, set the y limit between -2 to 2. This we are going to do for all the subplots. And then the y-axis labeled, it will be the amplitude keywords or words. This also will done for all the subplots. And the title, we need to insert a title, but this title only for subplot number 1. And we need to insert x labeled, which is x range, only for subplot number 3. And we need to insert the legend, which is the equation y1, y2, y3 for the old subplot. So let's do that. Let's define first x. So the x is equal to line space and the range between 0 to 10. So we can start 0 and 10 and the number of elements, for example, 100. And then define y1, which equal to sine x, and this time only sine x, not sine d, because the x is not degree, and we put semicolon. Y2 is equal to sine of 2 multiplied to x, and then y3 is equal to sine of 4 multiplied to x, and then semicolon. Just run to check that our input is okay, there is no error. And now it's finished because we can see that the blue line here, but we can't see the output because we suppress the output using semicolon. So we need to plot using 3 subplots, 3 rows, 1 column. So we can say the first one is subplot, 3 rows, 1 column, and the first one. And we will have subplot, 3 rows, 1 column, and the second one. And we will have subplot, which is 3 rows, 1 column, and number 3. So now I just made it for you to know that we have 3 rows, 1 column, and the B will be 1, 2, 3. And in the first one, we are going to plot, and let's write x, comma, y1. In the second will be plot x, comma, y2. And in the third, plot x, comma, y3. Let's run and check what will be the output. And the error here, subplot, it is small, not capital, and then run. And we run now, and we have the first one is sine x, the second one is sine 2x, the third one is sine 4x. Now we draw, and the limit between -1 to 1, -1 to 1, -1 to 1. If we adjust the y limit, and square bracket from -2 to 2, -2 to 2, and then run this section, because we write this in the first subplot only, so it will affect the first subplot only from -2 to 2. but the other is still the same. So if we need to do the same things for all, just copy and paste here, and then copy and paste here. So now we put y limit in the second, first, and third, run the section. And now we adjust the output to be from -2 to 2, -2 to 2, -2 to 2. And the other things, we need to write the y-x label, it will be amplitude. So we need to write this amplitude in the 3 subplot. It's very easy. We just need to write y label, and then we write the label, for example, amplitude, run the section. And because we only define the y-labeled amplitude only in the subplot number 1, it shows only for subplot number 1. And you may notice that the figure already duplicated. We will learn in the next video that we need sometimes to close the plot before drawing again and again. So what I'm going to do is, I just, starting from this code, write close all. And this close all, it's closing the figure window. So it will close all the open windows. So if we draw again, it will not keep the old one and put the new one. No, it will close all the previous and open the new one. We will learn that in the next video. So just run the section. And we run the section. And now we have the labeled amplitude only in the first one, because we only insert the y labeled only on the first subplot. So if we need for the other, still the same, just put in the second insert and then run the section again. And now we have the word amplitude for all subplots. And the third one, we need to insert the title, which having this keyword, the 3 sine waves. So we have this keyword we need to put, but only for subplot number 1. Which one is subplot number 1? We remember we take a note, say that subplot is counting from left to right, top to bottom. So here we have 1, 2, 3. From top to bottom, this should be 1. So we need to insert the title for the subplot number 1. So in the subplot number 1 here, we will add title, and inside the title we will put 3 sine wave, and just run the section. And now we have the title on the subplot number 1, say this is 3 sine waves, sine wave 1, sine wave 2, sine wave 3. And we need to insert on the x-axis labeled like the x range. So we need to put this one for subplot number 3. This subplot number 1, subplot number 2, this subplot number 3. So we are going to subplot number 3, and then we will write x label. And then inside that one, we are going to write x range and then run the section. And now we put x range on the third plot. And the last things we need to insert the legend, which is y1 equals sine x, y2 equals sine 2x, y3 equals sine 4x for all subplots. So we need to insert legend for each of them. So we write legend. And then in the first one, we are going to write y underscore 1, and then it equals sine x. And if we run this, we will have the legend in the first subplot. It's shown here. And to insert for the second, legend. And then we are going to write y2 is equal to sine 2x. And then for the third one, legend, we will have run the section. And we insert all the legend for all the plots. So we now answer all the questions for this practice. So let me sum up what we learned for this lecture. So for this lecture, we learn about in this one about the subplot. And subplot is kind of very simple command. Subplot and then number of rows, number of columns, and then the B, it means the index or the number of the plot we are going to draw. And the most important note is every subplot is kind of a unique part. So if you edit any things in this subplot, for example, insert the legend, the Y labeled, X labeled, the insert text, insert whatever you enter, it will not affect the other. It will affect only this subplot. That's all for this video. Thank you. Bye bye.